Good morning, students. So whether my screen is visible, I'm not.
Yes, sir.
Students. Okay, right, fine. So good morning. So welcome to the module 36 of ICE engine subjects. Right. So in this ICE engine subjects, today we are going to see about the water cooling and or liquid cooling or indirect cooling of ICE engines. Right. So in particularly for the water cooling engines, we have seen the many types already, right? So thermosipan and the pump assisted thermosipan, and for the thermostatic regulator we have seen in last class, right? So next we just give some recap about the previous water cooling systems, that is the thermosipan and the pump assisted, that is a forced circulation thermosipan cooling system, and the cooling with the thermostatic regulators, right? So in the liquid cooling system or water cooling system, right? So that system is mainly used water as a coolant, right? So the water is used and made to circulate through the jackets provided around the cylinder head, wall ports, seats, right? So etc. So where and all the heat will be extracts more, right? So that there the water jackets will be there, right? So it consists of a long flat and the thin walled tubes, you can see in this diagram, right? So here you may see, right? So here the blue color and the yellow and the orange. So the color changing one is the no. So that's right. So it consists of the long flat, right? Long flat and thin walled tube, right? So with an opening facing the water pump outlet and the number of small openings along its length that direct the water against the exhaust valves, right? It against the exhaust valve. The tube it's fitted in the water jacket and it can be removed from the front end of the engine block, right? So the heat is transferred from the cylinder valve and the other parts by the convection and the conduction method, right? So, for the heat transfer mode, right? So the water liquid, right? So it becomes heated and it passes through the jacket and it turns to cooled by means of the air cooled terms, air cooled radiators, right? So here you can see, right? So from the radiator, right? From the radiator, what will happen? The cool water or the liquid will come through the engine block, right? So it will have a flat and thin walled, right? Thin walled tube shape will be there, right? Around the engine valve cylinder, right? So it will carry the heat, right? It will carry the heat by the mode of heat transfer. Either it may be in convection or it may be a conduction, right? So by this term, the heat will be transferred and it will be passing through the cooling medium. That cooling medium is called the radiator, and the radiator will be runs with a fan, right? So it will be cooling, right? So it will be gets cooled, right? So again the hot water will be cools into the cold water, right? So this is the principle of the liquid cooling system. This is the principle of the liquid cooling system, right? So in this liquid cooling system or a water cooling system, we have plenty of types. So thermosipan, right? So generally the thermosipan, right? So means we have two tanks, right? So we have two tanks, right? So one is the lower tank and the upper tank, right? So we have two tanks, right? In between that we have a radiator, right? We have a radiator, right? Which is the water filled one, right? Which is the water filled one, right? So once the engine block, right? This is the engine block, right? Once the engine block will get heat, right? So on the time what will happen, the heat will be carried, the heat will be absorbed by the water. So if the heat will be absorbed by the water, so its density it surely varies, right? So because of it's a incompressible fluid, right? So for the incompressible fluid, it maybe depends on the temperature, right? So if the temperature will be increases, the density will be loses, right? So once the density will be loses, so it will be passes through the upper tank, right? Then here the density will be a low, right? So once the fan will be rotates, right? Once the fans will be rotates, so what will happen? The air, right? So the air will be, sorry, the air will be passing through the, right? So here the air will be passing in this direction, right? In this direction the air will be passing. So what will happen? Though the air will be cooled, the air will be cools the water, right? The hot condition water, so the density will be somewhat increases, so higher density will be passing through the lower tank due to the gravitational one, right? So this type of cooling system is called thermosiphon cooling system. Thermosiphon cooling system, right? Then some cases we required some pressurized fluid, right? We required some pressurized liquid into the engine block, right? So that time we have add some elements, right? So that element is mainly for the water pump and for the thermostat, right? So we have to here also the same, right? So thermosiphon cooling system, but the water supply will be in a forced manner, right? So we are using the pump, right? So the pump will be pushes the water, right, from the lower tank to the engine block, that is the water jacket passage, and it will carries the heat and it will goes into the upper tank, right? So again it will be cooled down by the radiator, right? So for the same, you can see here we have added the two, right? So water pump and the thermostat, right? So here this pump assistant means only the pump will be considered, right? So then the second one is the thermostatic regulator, right? The cooling with the thermostatic regulator, right? So this is the difference between the thermosiphon and the pump thermosiphon and the cooling with a thermostatic regulator, right? So in this thermostatic regulator, how it can be worked means in this thermostatic, most probably why we have to use this thermostatic means, while if how the pump will be runs means, if the engine will be in starting condition, then the pumps will be, the water pump will get power and it will be runs, right? So once the engine will be switched off, once the engine will be stopped, right, then the pump work will be stopped, right? So on the time the engine may have some hot condition, right? So at that time the engine temperature has to be reduced, right? It will be required some cooling purpose, cooling required, right? So on the time how the thermostat will be works means, so due to the temperature difference, right? So, due to the temperature difference it may works, right? So how it can be works means, so the thermostatic having the blows, right? The thermostatic having the blows may be made up of the copper and the bronze, right? So inside the blows we have a liquid, right? We have a liquid, right? So that liquid, right, so that liquid will be expands, that liquid will be expands, right? So if the temperature difference is more, right, so the liquid will be expands, then the blow will be open this wall seat, right? So it will be expands, right? So initially the blow will be like this, right? So here the zigzag blow will be there, right? So once it will be expands means, so its gap will be increases, right? So it will lift the part, that it will lift the wall flow and it will create the flow of water. So flow of water from the engine block, that is the lower tank, to the engine block, and it will passes through the upper tank, right? So when while in the engine is stop condition, right? So switch off condition, then also due to the temperature difference it will be works, right? The cooling process will be taking place, right? Whether the engine will be somewhat in hot condition, if the engine will be switched off condition, right? So on the time also it will be works, right? So this type of cooling system is called the thermostatic regulator cooling system, right? Then the next one is the evaporative cooling system. Evaporative cooling system, right? So it is just a schematic diagram, right? So here you can see same the upper tank, the lower tank, then the vent cap, then the pump and engine block, right? So the water will be flows in this the arrowhead diagram, right? So the water will be flows the diagram. It will shows the direction of the water flow, right? Then how you can see, right? So in the system, it's predominantly used in the stationary engines, right? So most of this type of the evaporative, right? The evaporative um, cooling system, right? The evaporative cooling system is most probably used in the stationary engines, right? So in this, the engine is in the engine will be cooled because of the evaporation of the water in the cylinder jackets in the into the steam condition, right? Cylinder jackets into the steam condition, right? So here the advantage is taken from the latent heat, right? So the high latent heat of the vaporization of water by allowing it to evaporate in the cylinder jacket. So that's the main advantage, right? So if the steam is formed, right? So at a pressure above the atmospheric pressure, the temperature will be the above, right, to the normal permissible temperature. Normal permissible temperature. You can see this diagram, right? So in this diagram, the evaporative cooling system with air cooled condenser is there, right? So here uh, the evaporative cooling system with air cooled condenser is there. So in this case, the water is circulated by the pump. So here you can see the A, right? We have marked here as a A. Right. So this is the pump, right? So this is the pump, right? So it will be indicated as the A, right? So the water will be circulated by the pump A, and when it will delivers to the overhead tank B, right? So the tank will be the radiator cap, the vent cap, right? So in this diagram you can see, right, the vents in the cap, it is the radiator tank, that is the radiator tank, right? So when it is delivered to the overhead tank B, right? Then the part of its boiling cut off one, right? So the tank has the partitions, right? So you may see how the radiator will be there. The radiator will have the several partitions, right? So பார்த்திருக்கீங்களா இல்ல இப்ப radiator பார்த்திருக்கீங்களா இல்ல just you can open the radiator, it will have the several partitions. அத பார்த்திருக்கீங்களா? Anyone? Anyone?
Yes, sir.
Yes, right. Then the vapor arises above the partition, and because of the condensing action, the radiator tubes, right? So on the radiator tubes and சொல்லிப்போம் D அப்படி சொல்லி இங்க மென்ஷன் பண்ணிருக்கோம், right? So here the partition will be mentioned as C, and the D will be the radiator tubes, right? So the radiator tubes, the condense the flow into the lower tank E, right? So lower the water level tank will be E, right? So the lower tank E, from which it picks up the water, right? It picks up the water and it will be returns to the tank B, right? So it will returns to the tank B by the small pump, right? So here we have a small pump, right? So here we have a small pump, right? So the pump again it will be passes the water to the upper tank, right? So the water will be circulated, right, from B tank to E tank, right? So here we have two pumps, right? Here we have the two pumps, right? One is the A pump and one is the F pump, right? Then the vertical pipe G, right? So you may see here we have a vertical pipe, right? So it is a vertical pipe, right? So the vertical pipe G is communication with the outside the atmosphere, right? So it is communicated with the outside the atmosphere to prevent the collapsing of the upper tank, that is B tank, to the lower tank E tank, right? So when the pressure inside them is due to the condensation falls below the atmospheric level, right? So this type of the cooling system is called the evaporative cooling system, right? So here the evaporative cooling system will be assisted with water cooled condenser also, right? So in this diagram here it is a air cooled condenser, and here it will be a water cooled condenser, right? So in the water cooled condenser, in this case the condensation of the vapor formed in the over tank, that is the B tank, right? Overhead tank, right? So that is the B tank occurs in the heat exchangers, right? The heat exchanger, you may see the diagram here, the C, right? So here the heat exchange, right? So here see, it is the heat exchanger, right? So how the heat exchanger works means, heat exchanger is used to transfer the heat from the hot body to the cold body, right? So here most of condition this type of heat exchangers, right? So here the heat exchanger will be either parallel flow or a cross flow. Most probably we are using the cross flow heat exchanger will be used in the automobile engines, right? So how the cross flow will works means, so for the heat exchanger like this, right? So once the hot gases will be passing through this inner pipeline, right? Then the cold water will be passing through in this direction. Then it will absorb the heat, right? It will absorb the heat from the this pipe, and it will be comes into the hot condition, right? So here we are supply the cold water, and here we can get the hot water, right? So here the direction, right? So if the direction will be the same, right? So the flow of hot fluid medium and the other medium, right? So the flow will be in the same direction means this type is called the parallel flow heat exchanger, right? So if it is in opposite direction, right? So for example here you can see the cold water condition is same direction, but here the hot fluid will be passing through in this direction means it is called the counter flow. It is called the counter flow heat exchanger, right? So here we are using the heat exchanger C, right? So this part will be the heat exchanger. Here you may see, so this direction, right? So the it will be in a counter flow, right? It will be a counter flow. Why? Because the hot fluid will be in this direction, right? So the water will be circulated from here to here, from here to here, right? So the heat exchanger will be used. So the heat exchanger will be used here, right? So the heat exchanger is cooled by the secondary water circuit, and the water returns to the B tank by the gravitational one, right? A B tank by the gravity, right? So the pump A, the pump A is circulates the cooling water to the engine block, right? So pump A circulates the cooling water to the engine block, and the heated water from the engine block is delivered to the tank B, right? So they delivered to the tank B, right? So you can see this diagram is a very simple diagram, right? So the cooling water, right? So cooling water will be pumps, right? So cooling water will be, right, the cooling water will be pumps from the pump A, and it will be passing through the engine block, and from the engine block it will absorb the heat, and it will be goes into the tank B, and it will be goes into the tank B. And here the evaporation process will be starts, right? Here the evaporation status will be starts, and you can see once it will be evaporated, so it will create the steam, right? So once it will be evaporated means you will create a steam. That steam will be passing through the exchanger, right? So that steam will be passing through the exchanger, and it will returns back to the uh, B, right? And it will be returns back to the tank, and it will be passing through the tube to the pump, right? So it is the circulated one, right? It is the circulated one, right? So here what is the purpose of the condenser, right? Here what is the purpose of the condenser, and what is the purpose of the heat exchanger, right? So it will not reduce any pressure terms, right? But it will cools, right? It will cools the water, right? So this type of evaporative cooling system with the water cooled condenser, right? So here you can see the two types of the evaporative cooling, right? So two types of the evaporative cooling, right? So it's a very basic diagram. It's a very basic diagram, right? So in this diagram, we can give some basic about the evaporative cooling system, right? So the water, right? So here it is the lower tank, right? So most of condition, so here it is the water tank, right? So from the water tank, it is the water will be in cold condition, right? So water will be circulated through the pump, right? So it is called the A pump, right? It is called the A pump for the other diagrams, right? So here you can see the A pump, and here you can see the A pump, right? So from this pump, the water will be circulated to the engine block, right? So it will be sent to the engine block, and it will carries the heat, right? The water will be carries the heat from the engine, and it will be passing through the condenser, right? So passing through the tank level. So once the water will be gets heated, then we can get a steam, right? So that steam will be passing through the condenser. There the temperature will be reduces. Again the steam will be converted into water, and it will be passing through the same water tank, right? Then it will be pumps, right? Some cases what will happen, it will pumps the water from uh, the tank, lower tank to the upper tank, right? So this type of cooling system is called the evaporative cooling system, right? So in this evaporative cooling system, how the steam will be converted as the water, right? How the steam will be converted as a water means by means of one is air cooled condenser, or it may be a water cooled condenser, right? Or it may be a water cooled condenser. So most of conditions we are using the air cooled conditions. That term is called the radiator, right? Air cooled condenser, the term is called the radiator, right? So once you can see here the pump, right? The pump will be carries the heat of the engine, and it will be supplies to the radiator part. So the radiator part is called the air cooled condenser. The radiator part is called the air cooled condenser. So here what will happen, so here the hot gas air or hot water will be passing through the condenser, right? So here we have the two tanks, one is the B tank and one is the E tank, right? So what will happen, so the hot water will be passing through a small tubes, right? So the radiator will have a small tubes, so it will be passing through the small tubes, and here the fan will be rotates, right? So it will be cooled by the air which is produced from the fan, right? So the cooled water will be supplied to the tank E, right? So to the tank E, right? So in some conditions, depending upon the temperature, right? So here the one tube, right? So here one tube will be comes outside to the atmosphere, right? So that tube is a vertical tube, right? So that you can see here, right? So depending upon the temperature difference, what will happen? So here we have a small pump, right? So it will pumps the water again to the tank B, and it will be cooled, and it will be returned back to the tank E, right? Then the cooled water will be supplied to the engine block, right? So here the air will be the hot condition will be removed by the air cooled condenser, right? So here we have a water cooled condenser, right? Here we have a water cooled condenser, right? So is it clear? So what is the evaporative cooling system, right? So once the heat will be takes from the engine, surely the water will be converted as a steam, right? So that steam has to again it will be converted as a water, right? So how the term will be going on, that term is called a condensation process. The term is called the condensation process, right? So due to the evaporation of liquid, right? So that only it is called as the evaporative cooling system, right? So it is called as the evaporative cooling system, right? So is it clear? Is it clear?
Yes, sir.
Okay, right. Then we have pressurized water cooling system. We have the pressurized water cooling system. It is the last system, right? So in this last topic we have to cover our fourth unit, right? We have end up our fourth unit, right? So the pressurized water cooling system. So we already mentioned that the rate of heat transfer, the rate of heat transfer is depends upon the temperature difference between the two mediums, and where the area will be exposed to the atmosphere. for the air cooling, that is the direct cooling or air cooling itself, I already told that where the heat transfer will be maximum if the surface area will be maximum, right? If the surface area will be the maximum means the heat, the thermal conductivity will be high, right? So the fins, right? The fin surface area will be somewhat more means we have a good heat transfer rate, right? So the temperature difference between the two mediums, right? So the heat transfer rate is depends upon the temperature difference between the two mediums, right? And the area of the exposed surface and the conductivity of the material, right? So depending upon these, the heat transfer rate may be varies, right? So in the case of the radiators, in order to reduce the size of the radiator, it is proposed to seal the cooling system from the atmosphere, and it will to allow a certain amount of the pressure to build up the system, right? So that the advantage may be taken by the fact that the temperature of the boiling point of water increases as the pressure will be increases, as the pressure will be increases. You may note this one, right? The temperature of the boiling point of water, the temperature of the boiling point of the water increases as the pressure will be increases, right? So in the pressure cooling system, this type of the pressure cooling system, the moderate pressures, right? So about up to 2 bar pressure, right? Up to 2 bar pressure will be commonly used, right? So in this diagram you can see a cap is fitted, right? In this diagram you can see that the cap is fitted with the two valves, right? So that is one is a safety valve, right? So which is loaded by the compression spring, right? So the safety valve, that's the first one, the safety valve, right? So here the safety valve, right? So which is loaded by a compression spring, right? And the second valve will be the vacuum valve. The second valve will be the vacuum valve, right? So here it is the cap, right? So the cap is fitted with the two valves, right? So one is the safety valve and the vacuum valve, right? So when the coolant is cold, right, both the valves will be the shut, but uh, the engine will be somewhat warm up, right? The coolant temperature will be rises until it reaches the certain preset values, right? So how the spring will be moves, right? So it will be moves by some preset values corresponding to the pressure, right? So if the pressure will be increases, then the valve will be opens, right? So otherwise the valve will be in shut off position, right? So when the coolant will be in cold condition, right, so there is no temperature rise, so there is no pressure rise, right? So on the time the safety valve and the vacuum valve will be in closed condition, that is the shut condition, right? So if the engine will be starts, right? So if the engine will be starts, what will happen? The engine will get some warm up condition, so the coolant temperature will be rises, right? The coolant temperature will be rises, so until it reaches some temperature, until it reaches some pressure, right? So it will be in closed condition, right? So when the safety valve will be opens, when the safety valve will be opens, but if the coolant temperature falls during the engine operation, the valve will close again until the temperature rises again, right? So that will be most of conditions you may see uh, in the car engine, in the car engine the radiator fan, right? So how the radiator fan will be runs, sometimes the fan will be run and sometimes the fan will be in off condition. Have you noticed that one? அதை பார்த்துருக்கீங்களாப்பா, அந்த ஃபேன் ஓடுறது முன்னாடி
Yes.
அந்த இது பார்த்துருப்பீங்களா? ரைட், அதை பார்த்தீங்கன்னா ஒரு சில டைம் ஓடும், ஒரு சில டைம் so same. So when the coolant temperature will be rises, right? So but engine நம்மளுக்கு என்ன ரன் ஆயிட்டு தான் இருக்கும். So the engine will be runs, but the temperature, right? So the coolant temperature will be rises to the certain level, then only the safety valve will be opens, then it will be runs, right? So the pressure will here, it will be a very important one, right? So due to the pressure, right, due to the pressure the valve will be opens, right? The safety valve will be opens and the cooling will be occurs, right? So when the engine will be switched off, right, the coolant cools down by the vacuum, right? So once the coolant will be cools down, right? So the vacuum becomes to form the cooling system, right? To form the cooling system, but in the internal pressure falls below the atmospheric, the vacuum valves will be opened by the higher outside pressure, right? The higher outside pressure and the cooling system, then it attains the atmospheric pressure, right? So safety device is incorporated in this filler cap. So if an engine attempts to make unscrew it, right? So if it is we are made to unscrew it, then the valve conditions, right? Right. So then uh, you may see the radiator cap, right? So the radiator cap, so how we can remove the radiator cap? We have to press and we have to remove, right? So that is called the unscrewed method, right? So if you are an attempt to make the unscrew while the system is in under pressure, right? So the first moment of the cap, once it will reveals the pressure, then thus it will prevent the emission of the scaling scheme, right? So steam will be there, right? So the slanting of the scheme and the blowing of the cap due to the high internal pressures, right? So you may feel இது நிறைய டைம் நம்ம பார்த்துருப்போம், right? So how the radiator cap, sometimes the radiator cap will be looses and the radiator cap will be removed, right? So how means due to this pressure condition, due to the pressure condition, right? So this type of the cooling system is called the pressurized water cooling system, right? So in our IC engine, all the cooling system will be incorporated, right? So இப்போ நான் பார்த்த கூலிங் சிஸ்டம்ஸ் எல்லாமே எப்படி இருக்கும்? இன்கார்பரேட்டட். சரி, ஒரு இதுல வந்து ப்ரெஷர் வால்யூம் கூலிங் சிஸ்டம் மட்டும் தான் இருக்குமான்னா கிடையாது, ரைட்டா? So nowadays we are using the cooling system. All the type of cooling system will be considered. All the type of cooling system will be used in a single cooling system of any vehicle, ரைட்டா? So எல்லா வெஹிக்கிளும் எப்படி இருக்கும்? So எல்லா type of the valves use பண்ணிருப்பாங்க. So here you may see the compression spring, right? So here one is the safety valve, here it is the vacuum valve, right? So here it is a total term is called the cap, right? So the cap will be consist of the two valves, one is the safety valve and the vacuum valve, right? So if the coolant will be somewhat get warm up, somewhat get heat up, right? Then the uh, pressure will be arises, then the pressure will be arises, then due to the pressure variation, due to the pressure rises, then the valve will be opens, right? So this type of cooling system is called the pressurized cooling system, right? This type of cooling system is called pressurized cooling system, right? Then we have some advantages and limitations, right? So that we can see in the next class, right? So next class we can see uh, the advantages and the disadvantages of the liquid cooling system, that is a water cooling system, right? So whether we have a time or not, okay, right? Still 5 minutes is there, right? Still 5 minutes. Any doubt about this water cooling system, or the advantages we can proceed? Anyone? Okay, right, fine. Then we have some advantages on the cooling, that is a liquid cooling system, right? So it is a compact design of the engine with the appropriate the small frontal area is possible, right? So most of instance you may see where the cooling system will be there, right? So in the front of the engine, right? So in the front of the engine the small area will be a possible one, right? So the smaller frontal area is possible for the cooling system, so it is somewhat compact design of the engine, right? Then the fuel consumption of the higher compression liquid, that is a water cooled engines, or rather lower than the air cooled engines. So where the performance will be high means the water cooled engines will get some higher performance while comparing to the direct cooling condition, that is air cooled condition, air cooled system, right? So because of even the cooling of the cylinder barrel and head due to the jacketing, the making it possible to reduce the cylinder head and the valve seat temperatures, right? Then in the case of the water cooled engines, in the case of the water cooled engines, the installation is not necessarily at the front of the engine, right? So maybe uh, the cooling system is conveniently located wherever it may be a required one, so it is not a mandatory one for it is in the term of the front area, right? So wherever our convenient, right, so wherever the space will be there, there we can uh, allocate, there we can locate our the cooling system, right? So but it is not possible for the air cooled engines, right? It is not possible for the air cooled engines. Why? Because in the air cooled engines there may be a fins, right? So the fin will be attached to the cylinder valve itself, right? But in the water cooling system, in that water cooling system, it is not a mandatory one, right? So where the location will be there, there we can fix our the this system, right? So only the water will be flows through the jacket, water jacket passage, and it will carries the hot water, right? It will enters into the cold water and it will be come out with the hot water, right? So that hot water again it will be has to be cooling, right? So due to that cooling process, we require the thermosiphon, then the forced circulation radiator, then the thermostatic regulator, then the pressure evaporator, right? Evaporative cooling, right? So whatever maybe it requires in a separate part, but in the air cooling it's not like that. So for the air cooling, the fins will be fitted, the fins will be connected, that is manufactured, or it may be connected with the cylinder valve in direct manner, right? So the water cooled system, the water cooling system will be located anywhere, right? So whether the space will be there, we can locate, so anywhere the system we can install that one, right? But it is not possible in the case of the air cooling system. Then the size of the engine does not involve a serious problem, right? So far the design of the cooling system is concerned, right? So in the case of the air cooled engines, particularly for the high horsepower ranges, difficultly to encountered with the circulation of the quantity of the air for the cooling purpose, right? So you may see for the nowadays the super bikes will have some radiator, right? So in olden days, you may see in our normal bike engines we have only the fins, but in some special bikes you may see in special bikes there the power will be high, the capacity will be high, right? So the engine capacity will be there, the high speed engines will be there, so the high horsepower will be there, right? So that type of engine will have the radiator, a small radiator will be there in the bike itself, right? So these are all the advantage of the cooling, that is a liquid cooling systems, right? Then so up to this we can stop the class, right? Up to this we can stop the class, remaining we can see in the next class, right? Remaining we can see in the next class. Okay, right. So do you have any doubt in this class? Do you have any doubt in this class? Oh, okay, right.
No, sir.
Okay, then join the other class at 11:30. Okay, thank you.
சார் அசைன்மெண்ட் எப்போ சார் சப்மிட் பண்ணலாம்?
அசைன்மெண்ட் போஸ்ட் பண்ணியிருக்கேன்ல.
ஆமா
அதான்
சார்.
டேட் சொல்லி நெக்ஸ்ட் ஃப்ரைடே சொல்லியிருந்தேன் இல்லையா? கம்மிங் ஃப்ரைடே.
எக்ஸாம்ஸ் அதனால